To learn more about the remarkable little computer at the heart of the guidance and navigation system, we talked with Mr. Albert Hopkins, Assistant Director of the Instrumentation Laboratory.
This computer is similar to its ground-based big brothers that are dominating our lives so much today, in that it's fundamentally a high-speed adding machine with the additional features of having a memory into which it can write results and from which it can take data, very much as an accountant has his ledger. And it has a self-contained list of instructions analogous to an accountant's training, so that this tells the computer what to do in sequence. If we look over here, I can show you more about how the computer operates. The adding machine of this computer is a high-speed arithmetic unit which carries out the fundamental arithmetic processes. All of the complex operations that we've seen today can be broken down into long lists of arithmetic. The arithmetic unit receives its data from a memory divided into two sections, and it puts its results back into the erasable portion of that memory. This is the portion which is similar to the accountant's ledger.
What is the fixed memory?
The fixed memory is unique to the space age. It is a memory which cannot be written into by the arithmetic unit, and it contains information which must last the entire mission. It's here for safety. This contains
location of stars and things you wouldn't want to forget.
That's right. This contains a list of instructions which are fed one at a time to the sequence generator, which generates all of the controls necessary to operate the entire computer. Input data, which comes from the angle measuring devices that we saw earlier, or the keyboard, comes in through input conditioning circuits and is available in the erasable memory. The arithmetic unit can operate upon this input data and compute results designed to be output. These results are placed in a particular portion of the erasable memory where they are sent through output conditioning circuits out to other instruments which need this data, such as, for instance, the displays or perhaps a rocket motor.
When you say this computer is very much like land-based computers, and yet I think of them as occupying bays of equipment. You've got all this squeezed into a little box. How did you do that?
Miniaturizing a computer like this requires a judicious choice among many quantities. It's first necessary to minimize the number of circuits which you use. It's necessary to minimize the size of the components which you use, and it's necessary to package them as tightly as possible. Now, this must not be carried too far. If it's carried too far, it can endanger the reliability of the computer, so that a compromise must be sought.
Now, what kinds of circuits are involved?
In the memory, and also in the power supplies and in the input-output of the computer, conventional components are used, with the exception of the fixed memory, piece of which we see here. This fixed memory is actually composed of magnetic cores with wires woven in and out, sewn in with a pattern, where the information here is in the pattern of the sewing. The remainder of the computer, the arithmetic unit, the sequence generator, the so-called connective tissue, the logic section, so-called, of the computer, is made up of a single type of unit. This is a microcircuit gate. 4,300 of these are used in the computer to make up this entire segment. These are packaged together tightly. They fit in a fairly small space and are interconnected in separate modules in one side of the computer.